final frontier. If you thought of space, your answer's not wrong, but it is incomplete. Because along with space, the underwater world, which we study through hydrology, is one we have yet to discover. So we study underwater caves because they give us insight into past and present issues of pollution and climate change. So the first topic we'll look at is groundwater pollution, which gives us insight into current and past issues of pollution. Groundwater is found in the saturated zone of the Earth, from just below the Earth's surface to deep below. It's important because it contributes a small but significant portion of our supply of fresh water, which is slowly diminishing due to pollution and nitrogen deposits. So we focused on the Floridan karsts, which are a topographical area formed by the dissolution of soluble rocks and contain a drainage system which includes sinkholes and caves. So one of the issues with our groundwater is nitrogen deposits and pollution. It can come from natural and anthropogenic or man-made sources, such as animal waste or, as a 2010 study found, septic tanks. Because of the water and nitrogen cycles, nitrogen from the ground and from the atmosphere cycle into the groundwater, but along the way, some of it is picked up in processes such as ammonia volatilization, sorption, denitrification, and dilution. So there are a number of ways we can collect data on groundwater, including spring discharge, where we measure the spring flow velocity of the water, water chemistry, where we analyze organic compounds, dissolved gases, stable isotopes, and age tracers, and age dating, where they take water samples and look at chlorofluorocarbons and tritium, which are released through anthropogenic activity into the atmosphere. So once we have groundwater samples and data to analyze, we can look at the isotopes of nitrogen, oxygen, and hydrogen. Higher nitrate and oxygen concentrations indicate younger waters, for example, and we can look at ratios of same group elements, such as calcium and magnesium, and chloride and bromine. In this diagram, you can see that the nitrogen concentrations change when you look at different areas of Florida, and as a general trend, areas further inland have higher nitrate concentrations.
So now that we've looked at indicators of current climate conditions, we can look at indicators of past climate conditions, speleothem samples. So there are two types of speleothems. The first one is stalactites. Stalactites are typically found on the ceiling of the cave, and they have a very pointy end. And stalagmites are found on the bottom of the cave, and you can tell that they have a very rounded top, which means the precipitate has fallen from the ceiling. And so why do scientists study speleothems? They're considered paleoclimatic archives. So if you open one up, you can see the many different rings within it. And those rings have formed over tens of thousands of years, growing less than 1 millimeter each year. So if you look at what's inside those rings and what they represent, you can find out the temperature and conditions under which they were formed. Okay, so in order to understand why stalagmites are significant, we have to understand how they're formed. So first, it starts with rainwater. As rainwater falls, it's going to seep into the soil, and when this happens, it's going to react with carbon dioxide. When you have water and carbon dioxide, you have the formation of carbonic acid, which is a weak acid. Now, as it goes through the soil and it hits the top of the limestone, it's going to dissolve in calcite. And when it does this, we have the formation of calcium bicarbonate. And it's important to remember that if you just pour water on top of calcium carbonate, it's not just going to automatically create stalagmites. You have to have a weak acid because carbonates are not soluble in pure water. And so now the water containing calcite is going to hit the entrance of the cave. And when this happens, it's going to come into contact with the air. And now we have the carbon dioxide being released, and we just have the calcite and pure water left. We know that calcite isn't soluble in pure water, so the calcite is going to precipitate onto the ground. And over time, you have the formation of stalagmites because the precipitate builds and builds and builds. And sometimes the water may come into the cave, forming underwater caves with stalagmites. And scientists look at two isotopes within the stalagmites to understand them. They're going to look at oxygen 18 and oxygen 16. Oxygen 16 is lighter than oxygen 18 because it has less neutrons, meaning it has less of a mass, and it's easier to take into the atmosphere than oxygen 18. And when looking at the ratio of these two isotopes, they can actually find out the climate conditions of when the stalagmite was formed. So scientists also analyze fluid inclusions within the stalagmites. When you open them up, you're going to find water-filled cavities most times. And within those water-filled cavities, you're going to have drip water. By analyzing the ratio of oxygen 18 and oxygen 16, you can actually find out the temperature at which the stalagmite was formed.
And finally, one last way that we study past climate change is through the analyzation of fossils. And in particular, we studied sloth fossils in western Cuba. So these fossils were found by Matthew Peros and his team of geographers. Two new species were found, one about the size of a dog, while the other was the size of a grizzly bear. While it's unclear how these fossils died, it is clear that they were there before the underwater cave was formed. And so, what do these fossils tell us? They tell us about, again, past climate change, but also the Pleistocene megafaunal extinction. So, how are these fossils studied? They're studied through this technique called radiocarbon dating, which is dependent on the existence of two isotopic forms of carbon, carbon-12 and carbon-14. Carbon-12, which makes up 99% of all carbon in nature, is stable, while carbon-14 is radioactive. How is carbon-14 formed? Well, when cosmic ray showers hit the upper atmosphere, neutrons are ejected from the nuclei of these atoms, and so these neutrons are then absorbed by nitrogen-14 in the atmosphere, which then replaces one of its protons. And so the nitrogen-14 is transformed into carbon-14 with 6 protons and 8 neutrons. So why is this relevant to radiocarbon dating? Well, carbon-12 and carbon-14, when in the form of carbon dioxide in nature, is recognized in the same way by plants and animals. Therefore, an equal ratio of carbon-12 to carbon-14 is absorbed by all living matter. And so all living matter has the same ratio of carbon-12 to carbon-14. When a living organism dies, the carbon-14 is no longer absorbed into its body, so the ratio of carbon-12 to carbon-14 decreases, and carbon-14 undergoes beta emission, which is when a neutron is transformed into a proton, an antineutrino, and an electron. And therefore, the carbon-14 then, because it loses one neutron and gains a proton, it is transformed back into nitrogen-14, the stable form of nitrogen. From the ratio of carbon-12 to carbon-14, scientists are able to then determine at what time did this organism die. One of the many ways that we do measure radiocarbon dating is through liquid scintillation, and this process is displayed here behind me in this diagram. Essentially what happens is the bone is excavated and ground into smaller pieces where it is treated with weak acid. From there, it is transformed through a series of chemical reactions into benzene, and the number of beta emission decays is measured per minute through a liquid scintillation machine, and calculations are then made from there to determine the approximate age of the organism. And so the sloth fossils were determined to be around 4,000 to 5,000 years old. Other methods of radiocarbon dating are through accelerator mass spectrometry and gas proportional counting. And while radiocarbon dating is currently the most popular way of dating fossils, it is probably also not the most accurate. In fact, because the fossils were found in underwater caves, some of the bone's collagen has degraded as a result of the water interactions. In addition, there is also up to a 5% deviation in all radiocarbon dating due to the change in atmospheric carbon-14. The radiocarbon dating of fossils is extremely important because these findings specifically showed that sloths in Cuba died actually 5,000 years after those in North America did. And so it shows that extinction was a gradual process, and the highest sea level rise did not occur until about 4,500 years ago. A lot of these findings can actually help scientists today determine a lot about climate change now because of their findings of the past. Overall, the study of groundwater pollution, stalactite and stalagmite samples, and radiocarbon dating of fossils in underwater caves gives us a clear picture of past and current conditions of the Earth through chemistry-based analysis.